we are going to finish up connecting equations to graphs. We started this in the last lesson, lesson 10. So here's part 2. Okay, let's warm up by, well, first, let's analyze different forms of linear equations and how the forms relate to their graphs. So let's start by writing each quotient as a sum or a difference. I could also say we're going to write each fraction as a fraction plus a fraction, or a fraction minus a fraction. Okay, here I've got a minus in between. Okay, I have a 2 in the denominator here. That means I need to split this up into 2 fractions. So I just did the difference. I rewrote this quotient as a difference. All right, and I can simplify that to 2x minus 5. So now it truly is a difference. There's no fraction there at all. So I just took that and I split it, and I made 2 underneath the first one and 2 underneath the second one with a minus in between. Here I have another minus, so I'm going to put that negative 2 under both the first term, which is the constant 1, and the second one, 50x over negative 2. We can simplify. I get negative 1/2 at the beginning, and then I have minus 50x over negative 2. That would be like this right here simplifies to negative 25, but then I have a negative that I need to include there, so that'd be plus 25x. All right. Here, we really need to distribute this first. Okay, I'm going to go over this way. So I get 5x plus 50 all over 25. Now I'm going to do the same thing that I did in the first few. I need to put that 25 over the first term, 5x, and the second term, just 50. And then simplify again. 5 over 25 simplifies to 1/5 x, and 50 over 25 simplifies to 2. So that would be my final answer. And I guess this would be my final answer. And that would be my final answer. Sorry, I cut off the 5. Okay, feeling pretty comfortable? Let's do the same thing here. I'm going to split that 2 up into both the first and the second term, so negative 1/5 x over 2, that looks funny, plus 5 over 2. Okay, this right here can simplify. You can grab your calculator and double check it, but negative 1/5 over 2 is the same as negative 1/10 x plus 5/2. I know when I go to graph these later, it's going to be very useful for me to have 5/2 as the decimal 2.5. Okay, so that would be your answer for those two. If you need help with those, please let me know, and I can practice it with you or show you exactly what I'm trying to do. Okay? So here are 2 graphs that represent the situations you have seen in earlier activities. We've talked about a tank losing water, and we've talked about dry figs and almonds. That's the trail mix. Both of those things. So there are 2 graphs that represent situations we've seen earlier. So the first graph represents A equals 450 minus 20t, which describes the relationship between gallons of water in a tank and time in minutes. We're going to have to go back and forth a little bit here. Where on the graph can we see the 450? Where can we see the minus 20? Well, the 450 is right here. And the minus 20 is actually the slope of the line. So we are decreasing 20 gallons for every 1 minute. Now, these are in 2 minutes. So it would actually be very helpful to say I'm decreasing in 40 gallons every 2 minutes. So if I decrease, let's change colors, 40 gallons, 2 minutes, I'd be right about there. And then 40 more gallons would be 10 and 30, about there. Yep. Subtract 40 again. So minus 40 plus 2, minus 40 plus 2, minus 40 plus 2, right? Minus 40 plus 2. That is the slope. Negative 40 in the y direction plus 2 in the x direction, or negative 40 gallons plus 2 minutes. And 450 would be at time equals 0. It's called the vertical intersection, vertical intercept. Okay, good vocabulary word for you. What do these numbers mean in this situation? 450 is the gallons at time equals 0. And negative 20 is the gallons of water lost each minute. Each minute. I don't know what this thing's doing, but it's bouncing. I don't want it to bounce. Okay, let's move on. So the second graph represents 6x plus 9y equals 75. So let's just change colors here. 6x plus 9y equals 75. All right, and I believe that is the cost of almonds, $6 for a pound of almonds, $9 per pound of figs, and we spent $75 altogether. See what we're doing with it. It describes the relationship between the pounds of almonds and figs and the dollar amount Claire spent on them. Suppose a classmate says, I'm not sure the graph represents 6x plus 9y equals 75 because I don't see the 6, 9, or the 75 on the graph. How would you show your classmate that the graph indeed represents this equation? Well, I honestly I'm messing up. I honestly look for where I cross the horizontal axis and where I cross the vertical axis as a very easy way to check things out. So where I cross the horizontal axis, I want y to be 0 there. So I'm going to figure out what's going on when y is 0. So that cancels that term out, and I have 6x equals 75. Divide both sides by 6, and I have x equals 12.5. So when y is 0, x should be 12.5. And look at that, it is. And that means that you have 12.5 pounds of almonds, 0 pounds of figs, and you've spent $75. Let's try the vertical intercept. That would be where x equals 0. So 6 times 0 plus 9y equals 75. So that cancels out. I'm left with, divide both sides by 9, y equals 8 1/3. That should be on my y-intercept, and it is. Okay, right there, which is 8 1/3. That represents 8 1/3 pounds of figs, 0 pounds of almonds, and I've spent $75 according to the equation. So can the equation be rearranged into an equivalent equation, 8 1/3 minus 2/3 x? What steps would you use? I think we're missing some things here because that's not enough. I don't have an equal sign. Let me see if there's a typo. Still looking. Yep. All right. Sorry. There we go. This should be y equals 8 1/3 minus 2/3 x. What steps would you use? So let's try it. I'm going to take the original equation right down here. What was it? I've already forgotten. Which one's x, which one's y? Oh, for goodness sakes. 6x 9y. Sorry. So I have 6x plus 9y equals 75. So let's solve this for y, like that one is up there. So I'm going to subtract 6x from both sides, and I will get 9y equals 75 minus 6x. And then I'm going to divide everything by 9. And just like in the warm-up, that means I have to divide that by 9 and that by 9. So y equals 75 over 9 minus 6 over 9x. So if I check my work, 75 over 9 is equal to 8 1/3, and 6 over 9 is equal to 2/3 x. All right, that's the steps I would use. And can you see 8 1/3 on the graph? Yes. Can we see the negative 2/3 on the graph? Let's look. So let's go to here. So at that point, I am crossing, I call them hatch marks on the graph. I see the grid where my line crosses things that I can read. Now I want to try to find negative 2/3 on the graph. I know that's my slope. So let's look at it. So if I go down 2, so negative 2, because that's my change in y, and over 3, 1, 2, 3, I'm still on the line. Down 2, over 3, still on the line. If I go up 2 and left 3, I'm still on the line. Okay, so negative 2/3 is the slope. Okay, pretty cool. All right, so let's try this again with some slope matching. All right, so match each of the equations with the slope m and y-intercept of its graph. So everything is not quite in the right format. So I'm going to color code a little bit because I need places to work. If I rearrange this equation to try to get it into slope-intercept form, I have negative 4x plus 3y equals 3. I'm going to go ahead and add 4x to each side. So I have 3y equals 4x plus 3, and then divide everything by 3. That means y equals 4/3 x plus 1. So my slope is 4/3, and my y-intercept is 1. So that would be B, matches with 1. Okay, let's try 2. I'm going to work over here. 12x minus 4y equals 8. Subtract 12x from both sides. I have negative 4y equals negative 12x plus 8. So divide by negative 4, divide by negative 4, divide by negative 4. That leaves me with y equals a positive 3, x minus 2. So I have a slope of positive 3 and a y-intercept of negative 2. Cool. All right, let's see if we can do a little bit of a shortcut with this one. See if you guys can do that. We're in pink now. So I know I need y by itself, so I'm going to divide by 2, divide by 2, and divide by 2. Okay, that leaves me with 4x plus y equals 8. Now I know I have to move that over, and that gives me a negative 4 of a slope and a y-intercept of 8. So maybe you can pull out the pieces and the parts without doing all of the math. Okay, let's try this one. Ooh, that one's a little harder, so I'm going to write that over here. Negative x plus 1/3 y equals 1/3. Well, I can't have a 1/3 in front of a y, so how do I get rid of a 1/3? Well, I need to multiply everything by 3. So that gives me negative 3x plus y equals 1. So to put it in the right form, I need to move this over to the other side of the equal sign, which makes it positive, and my y-intercept is 1. So I see this is my equation. And the last one. Looks like I wanted to divide everything by 3. And that leaves the number in front of the x, 4/3, but it has to move over. So it's going to be a positive 4/3. And my y-intercept would be a -2. So I did a few of the problems the long way, and I did a few of the problems shortcut way in hopes that that would help. All right, so how would you describe the matching process or the strategy? Was it fairly efficient or laborious? Was it prone to errors? Yes, it's prone to errors. The first few times we did all the steps, I would call it laborious. Kind of efficient when we skipped some steps, but still prone to errors. Okay, if the list of slopes and y-intercepts were not available for you to choose from, would you still be able to determine the slope and y-intercept? Yes, by always solving for the y and getting it into this form, where that's my slope, the number in front of the x, which we call m, and it stands for slope, and the constant all by itself, which is the y-intercept, which is b in the equation. And again, I don't know why the slope is labeled m and the y-intercept is labeled b. I don't know why she swallowed the fly. Perhaps she'll die. It's okay. It's okay. Sorry, they want to vacuum. So would you still use graphs to make matches if graphing needed to be done by hand? I don't use graphs to make matches. I just do the algebra. If we wanted to graph to make the matches, you know, we'd be coming over here into GeoGebra and graphing all the lines, and it would be laborious. Okay, we're going to do a few of them though. So if you want to go over, and it's not GeoGebra, it's Desmos. So if you wanted to go over into Desmos, I'm looking at the same worksheet that you had previously. I'm going to type in number 1, which is -4x plus 3y equals 3. So my y-intercept is 1, which we match that. In the slope here, we'd have to count it. I go up 1, 2, 3, 4, 1, 2, 3. So if I match, these points, I can count it 1, 2, 3, 4, 1, 2, 3 until I see another point just like it. Okay, so that slope is +4 over +3, and my y-intercept is 1, 1, 0, 1, and that would be the B option. So if I go back over here, that was B, okay? So I actually think graphing is much more laborious, especially if you don't have anything digital to graph with. That's really why I didn't go the digital route in the first place. I didn't do the graphing route. All right. So connecting equations to graphs. Part 2. Suppose Claire went back to the store to get more almonds and dried figs and spent $108 this time. Almonds cost $6 a pound and dry figs cost $9 a pound. Claire's purchase can be represented by the equation given. Here are 2 graphs that represent the relationships between the almonds and the figs. Okay, graph A and graph B. Without calculating, can you tell which graph would represent that equation? Well, we're going to come over here, okay? We're back over here. I'm just going to do that first equation. I've already forgotten it. Which one's 9? Which one's 6? I don't know why I have such an issue with this equation. 6x, 9y. So 6x plus 9y equals 75. Okay, that's my equation. Now, what if we had more money to spend? What's that going to do? Okay, if we go to the equation that looks like this, okay, that doesn't work. I still have 6x plus 9y, but now I'm equal to, was it 108? Already forgotten. $108. Okay, it's the same slope of the graph, we just have more money to spend. All right, my y-intercept is now 12, which makes sense. If I do 108 divide by 6, I should get 12. I get 18. Y-intercept is where x is 0. 108 divided by 9 is 12. 18 is over here. Oh gosh. So many buttons. Okay, so if we go back to the question, graph B is the only one that makes sense because as we buy almonds, we have to buy less figs. As we buy more figs, we have to buy less almonds. Okay, this right here is like, I have as much money in the world as I want. I keep on spending. I'm never going to run out. That doesn't work. Okay, the vertical intercept in this situation always means how many figs you can buy if you buy no almonds. Okay, the vertical intercept here is 12. And we find it by putting in 0 for x. Oops, 108. So if I divide both sides by 9, I'm left with y equals 12. And my ordered pair is 0, 12 because I plugged in 0 for x. All right, the slope of the graph is going to be 108. Y, so 6x plus 9y equals 108. I'm going to subtract 6x from both sides. And 9y equals negative 6x plus 108. And then divide everything by 9. Amazingly enough, it's not amazing. The slope has not changed because the slope is the relationship between the almonds and the figs, and that ratio has not changed. 6 and 9 is still the ratio between the almonds and the figs. We can reduce it, but it's going to be an equivalent fraction. And if you look at the graph we did, our lines are parallel. Oops, sorry. If you look at the graph, the lines are perfectly parallel. All right, consider this equation. For each question, explain or show your reasoning. If we graph the equation, what's the slope of the graph? It's going to be 4.5. Nope. 1.5 over 4.5, which doesn't make sense. So if I double this, it would be 3 over 9, which is 1/3. If we graph the equation, what's the slope of the graph? Okay, it's 1/3, or 1.5 over 4.5. Where does the graph intersect the y-axis? It's where x equals 0. So if I take 18 and divide by 4.5, I get 4. So it intersects the y-axis where x equals 0, plug 0 in, and solve for y, and I get 0, 4. And where does it intersect the x-axis? Put in 0 for y, and divide both sides by the x coefficient. So that would be 18 divided by 1.5, and I get 12, 0, because 0 was plugged in for y, which is what we need to do when we want the x-axis. And that's it. That's my last slide.